Hello, I am Alex Sherstinsky, a developer relations engineer at Predibase. Today, I'm going to do a quick overview of fine-tuning large language models for a summarization use case. First, we import the relevant classes and methods. Then we get our API token from the Predibase user interface and use it as an argument to instantiate the Predibase client, and we will get a friendly message printed on the screen or in the logs with our user ID and username. We will then prepare the data set. For the summarization use case, we will use the SAMSUM dataset that is hosted at Hugging Face. SAMSUM is a very nice, well-curated dataset that is amenable for summarization experimentation. We load it from Hugging Face, and we see that there are over 16,000 rows. And entries look like dialogues and their summaries. We will use 5,000 of these examples randomized for fine-tuning. We will use Llama 3.1 8 billion parameter large language model. It is actually a small language model. We will fine-tune it on high-quality 5,000 examples from the SAMSUM dataset, and we will show that the fine-tuned performance on the summarization task will exceed that of GPT-4. So let's continue. For fine-tuning, we need an instruction prompt. It has a system part and a user part. So the system part, we will have a general description and an example, one-shot example. And in the user prompt, we will actually provide the dialogue and ask the model to summarize it. And as part of fine-tuning, the 5,000 summary examples will be paired with the input dialogues. And once fine-tuned, we will challenge the model with 500 unseen dialogues for evaluation. We will also wrap this prompt into the models prompt, which will include begin of text, start header, and other tokens that Llama 3.1 requires. As the next step, we will compute and plot some statistics on our data set so that we know the length of prompt and completion in order to come up with a proper configuration parameters for fine-tuning and later inference. We see that the dialogues themselves go up to 1,000 tokens, with the mean being around 500 tokens. And this includes the prompt for instruction fine-tuning, as well as the model prompt. And the completion, being summaries, is relatively short, with the mean of about 35 tokens. And also before fine-tuning, we want to see how the base model performs. What is its quality before fine-tuning? So we will prompt the base Llama 3.1 8 billion parameter model with our prompt, which contains these headers, the example, and a dialogue. We will prompt Predibase that will generate us the completion. We can see that the completion is a bit lengthy compared to the ground truth. We will note this and compare this result to the same experiment once we have fine-tuned an adapter. As part of the preparation for fine-tuning, we will create the adapter repository in Predibase. This is the Python command to do that. We give it the repository name and the description. So the repository has been created. And finally, before we launch the fine-tuning run, we will connect our data set to Predibase. So we will specify the Predibase reference and the dataset data frame. This is a pandas data frame that we analyzed before, and the name of the dataset. Once the dataset has been connected, takes a few minutes on average. We can then launch the fine-tuning run. We launch the fine-tuning run with this command, and it took about an hour for the 5,000 training examples, 500 evaluation examples on the A100 GPU. While the adapter is being fine-tuned, you can observe the fine-tuning progress, including the learning curves, in the adapter repository and the version corresponding to your particular fine-tuning experiment. As you can see here, the best checkpoint is number 5, after which the evaluation loss went up, even though the training loss decreased, and the Predibase system picked the best checkpoint and reported its loss values right here. You can also check your configuration parameters in this tab. And now we prompt the fine-tuned adapter. So here we specify the adapter repository and the adapter version and some options such as temperature to control the model output, as well as the maximum number of tokens, which we learned from the data analysis. And here's the output. This output is more succinct than that of the base model and closer to the ground truth. We evaluated the 3 models shown here on 500 held out examples from the SAMSUM dataset. And the results are that the adapter fine-tuned on 5,000 examples with Predibase beats the performance of the base Llama 3.1 8 billion parameter model by 32%. And it exceeds the performance of GPT-4 by 21%. We hope that this quick overview was helpful. We will share this notebook so that you can run it and experiment with fine-tuning on the summarization use case with Predibase yourself. Thank you for watching, and please visit predibase.com and join our Discord community.